In this video, we'll discuss how to use the programming language that LEGO provides to create a Mindstorms robot that does things based on behaviors, and in this instance, we will have it explore a room by following the walls. Before I go on, let me introduce my robot. This is my robot. I'm calling it Exoscout. It has tank treads for steering. It has a bumper here that can tell if it's being hit from one side or the other or from the front because of the two touch sensors. It has an ultrasonic sensor here that's set off at an angle, and that helps it as it's going around the room to see not only the wall that's near it but any wall that's coming up in front. And then it's got some eyes and facial characteristics for character. Now that I've introduced my robot, let's discuss what behavior-based programming is. It's about having a series of different behaviors that will kick in at different times, and each behavior will tell the robot what to do when it has control of the robot. The nice thing about this design is that it's modular. You can create one behavior. For example, at the very bottom there, with the lowest priority, is a drive forward behavior. And once you've got that one working properly, you can add another behavior, such as the hug wall behavior that's on top of it. When you've got that working, you can add another one, and they all work together, and at any time you can see which portion of the code is controlling it. Whereas if you tried to do it in a big unstructured thing, you'd get an unstructured mess. It would be spaghetti code, and it would be really difficult to tweak your robot. Now, things aren't quite as simple as it looked in that last diagram. We actually have to split the behaviors into 3 different parts, at least if we're doing it with NXT-G. If you look on the left hand side, we've got behavior triggers. So drive forward is always active. That's its trigger. It's always going. Hug wall will trigger when we're far from the wall, and avoid wall will trigger when we're close to the wall, and escape when the bumper is being hit. And on the far right, you'll see that each behavior has a corresponding action. Drive forward drives forward. Hug wall arcs to the wall. Avoid wall arcs away from the wall. And escape will make the robot back up and turn after the bumper's been hit. And you'll see in the middle there we've got something called the arbiter. The arbiter is a decision maker. It looks at all the behaviors that want to have control of the robot, all of them that are triggered right now, and it chooses the one with the highest priority to be the one in control of the robot. We've got a behavior with a low priority that's always active, and that means if the robot's not doing anything else, it will do this. So the robot will always drive forward unless there's something more pressing for it to be doing. Let's say that the robot is far from the wall. Well, the hug wall behavior will trigger, and the arbiter will say, well, that's more important than driving forward, so the hug wall behavior action will take effect. Likewise, if we've got 3 different behaviors all trying to trigger, the one that is on the top with the highest priority will be the one that takes effect, and when it's done its job and is no longer being triggered, it will go down to the one below it that's still being triggered. And if everything with any kind of priority is not being triggered right now, we will go back to our base level behavior that's always active, and the robot will drive forward as it explores the room. So let's take a look at what this looks like, and then we'll dive into the code. The robot starts off, it's turning away. Now it's turning towards the wall, and here it will go straight. And as we come to another corner, it will start to turn towards the wall. The hug wall behavior takes effect. And it would avoided the wall, now it's going straight. And here it's hugging the wall. And it continues to hug the wall, but you'll see that it hits something, and the escape behavior takes priority. And now it's going away from the wall, but again it hits something, and escape takes priority. We're going to create an exploring robot that will wander around a room. and follow walls eventually. And we're going to do this with a behavior-based robotics method. So our first behavior is to tell the robot to drive. For every behavior, we're going to have a sequence beam. So we will put out the drive sequence beam here. And this part merely tells it that we want it to drive, that this behavior should be active. We're going to create a new variable, and we are going to call it doDrive. And we'll make it a logic variable that will be true or false. And what we want to do is we will go to our variable block here, and we are going to write into the doDrive variable the value of true. So doDrive will be true, and it will always be true because nowhere else are we going to set it false. So that's the first important step to create a variable, or to create this part of the behavior. Next, what we're going to do is we're going to create the section of the code called the arbiter that makes decisions about which behavior gets to be active. So I'm going to put a note here. This is the arbiter. And we are going to put a loop. And we're going to connect it so that this is a parallel sequence beam that is active. And the first thing we're going to do is we'll start with the lowest priority behavior, which is doDrive. And we're going to read from the variable. So read doDrive. And if it's true, let's see, we need a switch. And note how I wait for that to adjust. This switch is going to be based on a value. The value is a logic value. And if doDrive is true, then we're going to set the behavior to doDrive, or drive forward. So first we need to create a new variable, and we're going to call this one behavior. And it's going to be a text variable. That means that it can hold a sequence of letters. So it could be a word, for example. Now, we're going to write into our behavior, write into behavior, the value is going to be drive forward. So if doDrive is true, the behavior will be drive forward, assuming that nothing else is true and has a higher priority. Now we can make this take up less space by clicking on the switch here and turning off the flat view. So here's the true case and here's the false case. Nothing happens if it's false, but if it's true, this is what happens. I can no longer see where I wrote arbiter. I'm just going to move this down a little bit. There it is. And reconnect this. Alright. Now, the next phase is once the arbiters determine the action, well, first we're going to display what the action is that it finally determined. So we're going to use a display block, and we're going to display text. That position will be fine, and we want to read the text out of our behavior variable. Note that I'm letting it have time to adjust. Good. We're going to read the behavior, and I'm going to drop down the data port here and connect this text to this text and shrink the data port now so the behavior will be displayed on the screen. If we run this program right now, it should put this text on the screen, drive forward. I'm going to save it. Explore 01. That's good. I'm going to save frequently because the NXT-G environment is buggy. And this way, if my program breaks and there's nothing I can do to fix it, I can go back to an earlier version and keep working. Alright, let's put a comment in about what we've done here. So we'll display the active behavior. Good. Now finally the behavior can kick in. So what we want to do is we need a switch. And this switch, that's not a switch. The switch is going to be controlled by a value, and it's going to be controlled by text. We want more than two choices though, so we're going to turn off the flat view, and this means that I can add as many choices as I want. Oops, not by hitting that button. See, it adds more choices up here. Well, we're going to have one called error, and we're going to make that the default. So now that it's highlighted, I'm going to hit the star button, and it's the default. But you'll note these will move around. The system appears to sort them alphabetically for you. And we want one called drive forward. Note that you need to spell this to match how you spelled it here exactly. If you don't, it won't work. And we'll get rid of these other conditions for now. Okay, and again, I lost my default. So, I guess error is the default and it's just not showing it. Here, we'll just make it obvious. Error is now the default condition, and if we're in this error condition, what we're doing is default means if it doesn't match any of the other words here, it will go to the default, and we want to say malfunction for us to tell us that we are in an incorrect state, an incorrect behavior. So I'm just going to find malfunction in the list.
Malfunction.
Excellent. So if we're in an incorrect behavior, it will say malfunction. Next, we have to wire this up to the behavior. We've already got the variable block here. We can just wire it up like this. And sometimes your wires go through things and sometimes they're ugly. It's just the way it is, I'm afraid. If you really have problems with the wire, you can click on it and hit delete. Another thing you can do to make one wire disappear is click on the port where it's going into, and then it goes away. And lastly, if you've got a totally funky wire and you just can't fix it, if you move the block it's attached to, it usually goes away. It's strange, I've never seen it do it quite like that. Now then, if I can just highlight it, I can hit delete and it'll go away. I'll wire this back up again and wire this up. Now, if we are in the drive forward condition, we want the robot to drive forward. All of our behaviors, if possible, should take very little time. So, we're going to tell us to move. Let's see, and just verify. My motors are on ports B and C. I want to move forward. I want it to go forward unlimited. So basically it will get here and tell the motors to go, and they'll keep going until something else kicks in. And we might as well go at 100% power. I'm going to save this with a different name. And I'm going to put it on my robot and try it out. Okay, here's my robot with the single behavior to drive forward. So if I start it, it drives forward. It ignores the touch sensors and anything else, it just drives straight forward. Alright, if you're with me this far, we have got the basics in place for a behavior-based robot. It has this drive behavior here. The arbiter looks at all the behaviors, all one of them. We display the behavior to the screen, and then we act on the behavior. By the way, the word arbiter basically means the chooser. He gets to make the choice of which behavior is active. Now, let's add another behavior. It wasn't impressive that it bumped into things and kept on going. It should have an escape or avoid behavior. So, first we'll create ourselves a new variable. Let's see. We will call this we'll call it escape. Do escape. And again, it's logic. It will have a value of true if we want it to be active, or false otherwise. So, first things first, this is going to be in a loop because it will be constantly checking for this. Good. And this is our escape behavior. Now, I'll just wire this sequence beam up. So now we've got 3 sequence beams in parallel. And in this one, we want to check the status of our bump sensor or sensors. So if we had just one bump sensor, we could find it here as a sensor. Yes, it's a touch sensor. We'll put it here. Good. And I have a touch sensor on port 1. And we want to check if it's pressed. Some bumper designs work differently where you check if it's released. You don't typically want to check if it's bumped because that will be pressed and released, and it won't trigger if it's bumping into something and hasn't stopped bumping into it. Okay, then we can take that yes or no value out and we can plug it right into our variable. Let's see, our variable is doEscape. We will write the value, and the true or false doesn't matter here because it comes right out of there. See, that's why it's grayed out now. So if this is true that we're bumping something, that the sensor is pressed, then doEscape will be true. As a matter of fact, it happens that I've got 2 touch sensors on my robot, and I want it to trigger if either one of them is hitting something. So I can do this. The easiest way to duplicate things is to select them and then hold down Option on a Mac or Control on a Windows computer and just drag it and drop it where you want it. And I'm going to use this logic block here. The logic block lets me do an AND, or, XOR, or NOT. AND will be true if both touch sensors, let's configure this one. This touch sensor is on port 4, and again I want to know if it's pressed. And instead of putting the wire into there, I will put one into here and one into here, and the result will come into here. Now, on this logic block, if it's AND, it will be true if A is true and B is true. If it's OR, it will be true if A is true or B is true. And if it's XOR or exclusive OR, it will be true if A is true and B is false, or if A is false and B is true. So if only one of them is true. You don't normally use that. And NOT would just take one value and give you the inverse. So if A was true, the value coming out would be false. And if A was false, the value coming out would be true. But what we want is OR. So if this touch sensor is pressed or this touch sensor is pressed, the doEscape behavior will trigger. Okay, so right now we've said that this is what escape wants to do. Now we need to add some code in our arbiter here. It will be just like we did for the do drive. I'm going to copy this and hold down Control, hold down Option on the Mac, Control on Windows, and I let it adjust. Good. Unfortunately, the comments don't move. I'm going to get rid of them. Well, maybe I'll just move them. Alright, so instead of checking do drive, we check do escape. And if this is true, then the behavior should be escape. And we check do drive first, then we check this one. This one has a higher priority, it's done later, and as such, it doesn't matter if do drive is true. If do escape is true, it will change the behavior irregardless of what it was before this point. So the things with a higher priority always come later. And again, we'll display the active behavior, and now we're going to act on the behavior. I'm going to go to my switch and add a behavior, and I'll spell it escape. If I spell it wrong, then we will hear the error condition, which I'm clicking on it again and making it the default again. So here's the escape, and what we want it to do, now that it's got total control of the robot, is move backwards. Let's see, one rotation, yeah, that should be fine. Backwards one rotation, and then we want it to turn. Let's see, we can spin in place. Turn, one rotation, let's see. Well, I think my robot will turn 90 degrees if the motors turn about 800 degrees, and I'll have it coast afterwards. And what else do we want to do here? As soon as it's done this, it will come back out. All the behaviors will have a chance to have their say. Actually, they're going on all the time. It's as though they were happening at the same time. But the touch sensors will no longer be pressed, so the escape behavior will no longer be requesting to be active, and the do drive, which has stayed true, will be active, and so it will drive forward again. We might just have this say something when it starts escaping. We'll have the motor stop. Okay, stop. And then we will have it say something. Maybe we can have it say oof. We could always make it wait for a little bit before we do that. That wouldn't hurt for good measure. Wait, say 1/10 of a second. Wait time. Okay, wait 1/10 of a second, say oof, back up, turn around a bit, and then it will go forward again. We'll save this under a different name. You'll note that the save has disappeared from the menu. If I switch away from the program and back to it, it comes back. Save as Explorer 03, and I'm going to put down my robot and try it out. Okay, uploading now. Okay, here's the robot that will drive forward and escape when it hits a wall. Well, it's certainly exploring. Okay, we now have two behaviors working in there. It explores very well, but as you might have noticed, it wandered off into the wild blue yonder. What we want to do is have a behavior that makes it try to hug a wall. So here's what I'm going to do. I'll use my ultrasonic sensor and basically tell it, well, the behavior will be, we'll call it hug wall. So let's create our variable. Do hug wall. I'm just hitting tab here, and that changes to my variable, and it again is a logic variable. We want this to act in a loop because we're always going to be checking it. And this time I can't simply drag up from here. I have to hold down the shift key, and then I can drag from the sequence beam and add this sequence beam. Let's see, this is hug wall. So what we want to do is check the reading from the ultrasonic sensor. And I just want to see all the data ports on this. Here's the distance, but this one's yes or no. So let's go to centimeters here. And if it's within, actually if it's farther than, say, 60 centimeters from a wall, we want it to turn towards the wall. Since our ultrasonic sensor is on the right-hand side of the robot, we're going to want it to turn right. So, let's see, if it's greater than 60, we will put that true or false into our variable. And I wait. Good. This is do hug wall. We are writing into the variable the value coming out of here. This will be true or false. It will be true if the distance is greater than 60 centimeters. Alright, so we've got that behavior where it's asking for the behavior to become active, and we go down and we have to tell our arbiter about this now. And I will select one of these blocks and duplicate it. So if, and this is going to be, actually, I've got this in the wrong spot here. It needs to be a lower priority than the do escape behavior. Now, I haven't actually set it up yet, but let's just see how hard it is to move. Okay, so this should be do hug wall, and here the behavior becomes hug wall. So in order of priority, we've got driving forward, then hugging the wall is more important than that, and lastly, if we hit something, escaping is more important than hugging the wall. Speaking of which, in our escape, it turned farther than I wanted it to. I'm going to make this, say, 400 degrees. Now, we come to our switch here. We add a new behavior. We call this one hug wall. Let me just check that I spelled that the same as I did it here. Hug wall, good. And you could copy and paste those. And if it goes into that error state, you know you've spelled something wrong and you need to check and find out which one it is. Okay, error needs to be default. I'm highlighting it. I'm hitting the star on it. Good. Click on hug wall here. It becomes active. And in our hug wall behavior, when it has control over the robot, we want it to, well, turn towards the wall. And again, the ultrasonic sensor is on the right side of the robot, so if it curves towards the right, it will tend to come closer to the wall. So let's see, we'll make that 100%. We'll make it go an unlimited amount. So long as this behavior is active, it will keep telling it to do that again. And I think this will turn in the right direction. If it doesn't, I'll come back and fix it. I don't want it to spin in place, I want it to arc towards the wall. Maybe like that. Alright, and that should do it. I'll put it on my robot and try it out. Okay, the robot should now try to drive forward and escape if it hits something, and it should try to hug the wall. I'm starting fairly close to a wall here. Let's see what it does. Turning towards the wall. Alright, my hug wall behavior worked the way I expected to. It arced towards the wall until it hit it, but then it turned around and it turned the wrong way for it to hug the wall very well. So I'm going to find my escape behavior and tell it to spin the other way. Let's see. Here's where we spin. Okay, this should work better. And while I'm at it, we will make hug wall a little more obvious by making it make a tone for us. Let's see. Here's the sound. This is a good way to debug and see that you're in the certain part of the program that you expect you are, especially when it's hard to read the screen. We'll play a tone. Alright, we'll play an A. Oh, for half a second. We'll play it for, say, 1/10 of a second. And yeah, we can wait for completion. That might change how the robot functions just slightly. Yeah, I'll turn it off. Okay, so we should hear a tone coming out of it whenever it's trying to hug the wall. We shouldn't hear it any other time. So I will put this on my robot and try it out. Okay, here's the robot hugging the wall. It seems to me that there's a bug. The screen shows it's in the hug wall behavior, but I'm holding it close to a wall and it should be in the drive forward behavior. Alright, it looked like there was a bug, that it was always triggering that behavior, even when we were close. And it was handy that I could look at the screen and hold the robot and see what behavior it was trying to run. And there is in fact a bug. This has the ultrasonic sensor set for port 4. But my ultrasonic sensor is actually on port 2. So let's try it again. Here's my exploring robot. It will try to drive forward until it hits something, and then it will try to escape. And it will try to hug the wall, but it will only do that when it's far away from the wall. If it's close to the wall, it should just drive straight without trying to hug it. Let's see what it does when I run it here. Driving forward, there's no tone. It's hugging the wall, you can tell because it's making the tone. Alright, I'm going to save it with a different number. It worked remarkably better with the thing on the right port, and it was nice having the tone so we could tell that it was doing that behavior. It'd be nice if it didn't have to actually bump into the wall to stay away from it. So we're going to add a behavior to make it avoid the wall. It seems kind of contradictory, hugging the wall and avoiding it, but if we have our distances set in a sensible way, what we'll find is that it will follow the wall. So I'm just going to duplicate this now that it's set up properly. Holding down the Option key on my Mac. You can hold down the Control key if you're using Windows. And I'm going to hit the Shift key so that I can extend the sequence beam. And we will call this one Avoid Wall. And we will create ourselves a variable. edit, define variables, do avoid wall. Looks right. Close. So now what we're going to do is if the distance is less than, oh, say 80, yeah, 84 is good enough. If it's less than 84 centimeters, we want to, wait, this behavior kicks in if the distance is greater than 60 centimeters. Okay, we want a distance in between the two where it just goes straight. So we'll make it, if it's closer than 40 centimeters, that it should go into the avoid behavior. So this will set do avoid wall to be true when we're closer than 40 centimeters. Now we have to tell the arbiter about this new behavior. And where do we want it to go? Well, it's less important than the escape behavior, and it's more important than driving. It could go as a higher priority than the hugging the wall, or as a lower priority. Since the two shouldn't happen at the same time, it doesn't really matter. So, oops. And I wait for it to move. There we go. So now we look at the do avoid wall variable, and if this is true, a void wall becomes the current behavior. And we come to our switch here, and we hit the plus to add a new behavior, and we'll call this one avoid wall. We'll check the error one again and make it the default in case we spell something wrong. Alright, let's look at the hug wall. This is what it does. I'm just going to copy it. Let's see. I'm going to hold down Option or Control and move it out. And then I'm going to find the avoid wall and grab this again and move it in. So to avoid the wall, we just want to arc away from it. And we'll play a tone so we know this is active, but we'll play a different tone. There, that should work. And let's put on a robot and see what happens. Here is my robot. That should drive forward. It should try to hug the wall like it's doing now. And it should also try to avoid the wall when it gets too close to it. It appears that we've got another bug. Avoid wall never seems to be happening. So, I'm going to look at my behaviors here. Here's the hug wall behavior. When the distance is greater than 60 centimeters, it tells it do hug wall is true. Good. Here's avoid wall. When the distance is closer than 40 centimeters, it tells us that do avoid wall is true. That's good. We'll come down here to the arbiter. Do hug wall. Okay, and that sets the behavior to be hug wall. Do avoid wall. And that sets the behavior to be avoid wall. Looks good. Here's our escape, and that's correct. We display the behavior on the screen, and we act on it. Here's the avoid wall behavior, right? And it's turning away from it. Yes. Here's the hug wall behavior, and it's turning towards it. All right, there's nothing obvious in checking that. Okay, here's my robot. It's set to run the wrong program, which is what confused me last time. Now that I've got it set to run Explorer 5, it's close to the wall here at the start, so it should turn away from it and play a different tone to start into our avoid wall behavior. Let's see what it does. Now it's making the hug wall sound. I think it would be better if it turned a little more sharply. There, look, it's avoiding the wall. And now it's hugging the wall. And the escape behavior still had precedence over the other two. Now, if I want to tweak one behavior without affecting anything else, I certainly can. I want to make it so that when it hugs the wall, it does it more tightly. So, we find the hug wall behavior, and I don't want to spin in place, but just come short of that. Alright. And avoid wall. Does that need to be more tight? I guess we could try that. Why not? There we go. I'll put it on a robot. And here's our exploring robot tweaking. Tweak to take the corners more tightly. And that's a little too tight. Yes, much too tight. We made it hug the wall and turn too tightly. Now we're going to make it a little less tight, maybe right there, and call it good. I hope you've enjoyed this video and try to apply some behaviors to your next robot. By all means, take my code, play with it, see what sort of behaviors you can come up with that you can use with your sensors. This is a great way to build a robot, make it do something, then refine it and make it do something more. Best of luck to ya.